Hello students, you are once again welcome to the second session of Unit 2, and the course is still Curriculum Studies in Mathematics Education. My name is Justice Yosin Mensah. In this session, we shall be looking at sequencing subject matter in mathematics. At the end of the session, you should be able to explain the types of sequencing in mathematics and then also explain the factors that influence the sequencing of subject matter of school mathematics. In the last session, we looked at factors influencing the selection of subject matter. If you have any problem with any of them, don't hesitate to contact me. Sequence of subject matter means a temporal ordering of subject matter such that one item of subject matter is taught first, followed by another, and then in that order. So when we talk about sequencing, we are talking about how you are going to arrange the content that you are going to give your students so that it follows in a linear order. Basically, there are two types of sequencing when it comes to subject matter in mathematics. We are going to talk about the vertical sequencing and, of course, horizontal sequencing. So as I said in the introduction, we have two major types of sequencing in mathematics, and we have the vertical sequencing and horizontal sequencing. Now, when are this sequencing done? Sequencing is done when developing the mathematics curriculum. So when the mathematics curriculum developers look at the curriculum or are developing the curriculum, they use sequencing of topics. And then when we as teachers plan our teaching activities, we also use sequencing. Let's look at what we mean by vertical sequencing. This means the ordering of subject matter with respect to the grade or class. So this is done with respect to the class or the grade. And by grade or class, we mean kindergarten, primary, JHS, SHS, and so on. So when you sequence your subject matter with respect to the particular class or grade, then we have what we call vertical sequencing. Vertical sequencing is often called grade or class placement, as I have just said. Examples: set, function, and real number system. These are topics in the grade. So how are you going to sequence these topics with respect to the particular grade that you are looking at? So in conclusion, we are saying that when we say vertical sequencing, we are talking of ordering of subject matter with respect to the particular grade or class you are dealing with. For horizontal sequencing, it refers to the ordering of subject matter with respect to a particular course in a particular class of subject matter in a particular topic in a particular course. I'll take that again. When we say horizontal sequencing, we are talking about ordering subject matter with respect to a particular course in a particular class, or of subject matter in a particular topic in a particular course. So at this level, you see, we can relate this with horizontal line. You see, we are talking about the same level, but how do you sequence your subject matter at the same level? A particular class, let's say JHS 1. How do you sequence your subject matter at that particular level? If you are teaching a topic like sets in JHS 1, how do you sequence the body of knowledge? That is what we mean by horizontal sequencing. So in horizontal sequencing, the focus is on what should be learned in a particular class and how they should be ordered. So as I said, if you are teaching sets in JHS 1, how do you order that subject matter? Unlike the vertical that talks about a particular class or grade. So if you are teaching sets in JHS, how should it be ordered? If you are teaching subject matter in SHS, how should it be ordered? But for horizontal sequencing, we are looking at a particular class. Let's say JHS 1. You are teaching the topic sets. How do you order the subject matter with respect to that particular class? Items of subject matter can be arranged in increasing or decreasing utility. And in this place, when we talk of increasing and decreasing utility, normally when textbook authors place in their last chapters of their book the subject matter that can be omitted without introducing gaps in the student's knowledge, they are using what we call the decreasing utility. And also when they put in the first chapter of the subject matter, that is very easy for students. They are employing the principle of what? Increasing utility. So we have some topics that can be treated, even though they are high order topics, they can be treated without creating gap in the knowledge of students. If you start with that, then you are decreasing. So you start from the highest and you are decreasing, you are going down. But if you start with the easiest one and you proceed in that order, then we talk of increasing utility. Let's now focus or look at factors that influence the sequencing of subject matter. What are the factors? There are several of them, but in this lesson, we shall consider the following: prerequisite knowledge. Prerequisite knowledge. So we can argue it is arguably the most frequent factor that should be considered when sequencing subject matter, because we know mathematics is like building a house. You must start from the foundation, move on to the footing, and then proceed gradually till it gets to roofing stage. So you must consider the prerequisite knowledge before sequencing your subject matter. So what do you mean by that? If knowledge of P is necessary for the knowledge of the comprehension of Q, then P must what? Be taught before Q. As simple as that. For example, before using the abbreviated quantifiers, let's look at that. These quantifiers, you see all these symbols being used. If the student doesn't know what each of these symbols stand for, you cannot use it in a mathematics class. So before you teach this quantifier, you must explain the meaning of what each of these quantifiers mean. So for instance, this is for all x member of real numbers, there is a y which is also a member of real numbers, such that when you add the two numbers, you get 0. This is basically teaching about the additive inverse. The additive inverse. Any number plus its additive inverse will give you 0, which is the neutral element. So before you express that statement in using quantifiers, you must first of all explain what is meant by each of those quantifiers. So that is prerequisite knowledge, and that's if we employ this or if we consider this before sequencing our subject matter, we don't create gaps in students' knowledge. So everything follows in that order. The next factor that influences the sequencing of subject matter is familiarity. Familiarity. If you are familiar with something, what does it mean? Some topics selected for a course are more familiar to students than others. And it is true, because before you start teaching students, they might have had some prerequisite knowledge either from the previous level or from home. So for example, numeration system sets are normally treated first because we assume that students have learned to count and group before school. Set is all about grouping, putting elements in some kind of set using defined properties. So we assume that students learn how to count and order or group items before school. So normally when we are sequencing our subject matter, we normally start with the numeration system and sets. So many curriculum developers or teachers and textbook writers use familiarity to order the presentation of subject matter. Psychological and pedagogical grounds. This is grounded psychologically and pedagogically because what is familiar is less threatening. So what you know already, if you know how to drive, it is less threatening to drive than probably going to operate a machine. So what is familiar is less threatening than what you don't know. So hence students are likely to be motivated to do it or to study it if they are familiar with it. And research has also shown that students learn better when we as teachers teach from known, that is the familiar, to unfamiliar. The next is difficulty. Subject matter which are too difficult for students frustrate them. And I know you've all been through school at the SHS level, and you are frustrated by some topics in mathematics, or you were frustrated by some topics in mathematics which you think are so difficult. Teachers try to explain, but because you think the topic is too difficult, you don't have interest in doing them. So if the subject matter is difficult, students will be frustrated. So they may not be able to understand or do what is expected of them, if they think so, and may reduce their interest and motivation, as you all have passed through. So what do we do as teachers? So when students find subject matter difficult when it is taught by a teacher who does not explain subject matter clearly, or reviews or assign enough exercises, then students seem to see that subject matter as very difficult. So to tackle that particular issue, you must use varied methods of teaching, and that will make your teaching, especially when you employ ICT in teaching those concepts, you try to get students, or develop students' interests in the subject, and that will solve the problem. So you must use varied methods of teaching those difficult concepts. The next factor that influences sequencing of subject matter is abstractness. And when we say abstractness, this word comes from the Latin word that means draw something from. And what we mean by this is that abstracting occurs when an individual becomes cognizant of pattern or a set of familiarities among differences. So what we are saying here is that whatever subject matter cannot be related to the immediate environment of the student. So they have to identify some patterns and be cognizant with the pattern, and be able to draw similarities among them. So when concepts are abstract, students find it difficult to learn. And we can look at it. Example of such abstraction is from graphing series of quadratic functions. When you let students draw a lot of quadratic graphs, they'll be able to identify and generalize that it's either opens upwards or downwards. It opens upwards or downwards. These are the two categories of quadratic graphs that we can have. And this can be in increasing or decreasing abstractness. And when we say something is in increasing abstractness, we mean when you restricting conditions are removed. When you remove the restricting conditions from it, then it becomes something in increasing abstractness. For example, we have rectangles, parallelograms, quadrilaterals, and polygons. We all know polygons. In this set, polygons is what? The superset. And then it's followed by quadrilaterals, parallelograms, and then rectangles. So when you remove a restricting condition, and then it becomes what? An increasing abstractness. And then when we say decreasing abstractness, when you rather impose conditions, when more conditions are imposed, then the abstractness is what? Increasing. It's increasing. Then we have the next factor that influences sequencing of subject matter, that is the genetic principle. What do you mean by that? Klein 1966 proposed a genetic principle for ordering the presentation of subject matter. And what is basically saying that the order of presentation of mathematical ideas should be the same as the historical order of their invention or discovery. So, for example, negative numbers are taught after positive numbers because historically positive numbers were discovered before negative numbers. If you follow the history of the real number system, you realize that positive numbers were discovered before negative. So he is saying that in teaching something like the real number system, you should teach positive numbers before negative numbers. So imaginary numbers are taught after real numbers. Also, historically, after discovering the real number system, then mathematicians went further to discover what we call imaginary or complex numbers. So in teaching the concept of numbers, you should follow in that sequence. That is what Klein is saying by the genetic principle. And this principle, the sequence is also in either increasing abstractness or familiarity, and we can relate them to, because students know how to count, and counting deals with positive numbers, so we can also relate it to what? Familiarity and then abstractness. Hence, the genetic principle, although plausible enough, is not independent of the other factors. So we are saying that this principle sometimes take into account the other factors that we have talked about. The next factor is immediacy of application. If you apply something immediately, you have the interest of studying that thing. For example, if you want to drive, if you have a car parked at home, then you have that tendency, that interest in learning how to drive immediately. The same applies to mathematics. So when we say immediacy of application, it refers to the time of utility of the subject matter. When are the students going to use what you are going to teach? It also influences how you should sequence the subject matter. And it's also justified on psychological and pedagogical grounds, because if you are going to, this can be related to prerequisite knowledge. If the knowledge of P is needed for the knowledge of Q, then P must be taught first, and the students will have interest in that. So a student who sees the immediate utility of some subject matter is likely to be motivated to study it, as I've said earlier. Topics that are required to be known before other topics ought to be taught first. So as we said, prerequisite knowledge. If you need this knowledge to teach the other subjects, then utility comes in here. Limits before differentiation, indices before logarithm, real number system before operations on them, etc. So you can look at this. You need to teach limits before differentiation, because in differentiation, it builds on the knowledge of what? Limits. And you can give several examples of such situations. Ladies and gentlemen, we have come to the end of today's session, and as usual, I'm going to leave you with these 3 questions. You look at them and then discuss among yourselves.